All right, guys, let's take a look at a homework problem from section 4.4, which you can see is based on hyperbola, and this is going to be question number 2. As you can see, they're asking us to sketch the graph of a hyperbola, and of course, these equations will keep changing. So you can see in this example here, we have y plus 2 quantity to the second power divided by 4 minus the quantity x plus 1 to the second power equals 1. So just to show you from the textbook page of, you know, for your class, looking at the standard equations for a hyperbola, you can kind of scroll down here. So you can basically see when we have a hyperbola with a center at 0, 0, this is a equation where your graph will have a transverse axis on the x-axis. In that case, your x square function or the equation will have the x square as the first part. So you will have x squared over a square minus y squared equals b squared equals 1. And as you can see from the properties over here, you're going to be centered at 0, 0, and then you can see how we can come up with our transverse axis length, the coordinates for your vertices, where the foci for the hyperbola will be, and of course, what the equations of the asymptotes will be. Now, you will notice here when the hyperbola has a transverse axis on the y-axis, in that case, your equation will begin with the y square value first, right? So you can see that equation is going to be y squared over a square minus x squared over b squared equals 1. And then again, you can see all the different information here, the length of the transverse axis, the coordinates for your vertices, your foci, and then again, what the asymptotes, the equations for the asymptotes will look like. And then you can see this is going to be on the left-hand side, the graph that you see, this is going to be a graph for where the transverse axis is on the x-axis. And then, of course, over here on the right, you will see this is the graph for the transverse axis that is on the y-axis. And then as you scroll down, you will also see that when the equations are there we go. When the equations are not centered at 0, 0, but they have a center at a different point, which we're calling the center of HK. So you can see how your equation changes in that case. And then, of course, how that will affect your coordinates for the vertices, where the foci will be, and then, of course, the equations for your asymptotes also. And you can see if that's a hyperbola that's opening, basically up and down where the transverse axis is on the y-axis, then this is what the equation for that hyperbola will look like. And again, you can see how all of these values will change again. And then you can see the graphs for the two types of equation. So basically, when we have a transverse axis on the x-axis, I like to call them as a hyperbola opening left and right, because you can see the arms of the hyperbola are going to be, facing left and right. Whereas when the hyperbola has a transverse axis on the y-axis, you can kind of see the arms or the branches of the hyperbola, and you will see they will be opening up and down. So I think that's an easy way for you to like visualize what your hyperbolas will look like. So looking at this equation, you can see in our example for question 2, we definitely have the y coordinate value first, right? So that's of course telling you that our hyperbola is going to be centered at HK. So we will need that information because that's going to be crucial for the graphing part of it. And then of course, we also need to think about what the the asymptotes, the equations for the asymptotes will look like, because we will need that information also to be able to graph our hyperbola over here. So we want to start by finding out what our center will be, and then we also want to find what those equations will look like. Now, you can see in the textbook, they're telling you the equation for the asymptotes will be plus or minus A divided by B multiplied by the quantity X minus H plus K. But I can show you a quicker way of doing that. So let's start by finding the center of this hyperbola over here. So let's take a look at that. So remember your center, is going to be H comma K. So remember, this is always associated with the X value and this is the Y value. So our center for this guy, you can see the X is X plus 1. So that actually tells you the equation is technically X minus -1. So that's where the two negatives are making that into a positive. So that tells you your X coordinate for the center is going to be -1. And same kind of process for the Y value. So you can see it's Y plus 2, which tells you it's going to be Y minus -2. So that tells you the Y coordinate for the center is going to be at -2. Now, also we know this is a hyperbola that is opening up and down because the Y value is first. So the opening is up and down. So you can see this is the tool we will need to select when we are trying to graph this hyperbola. So we start by selecting that tool. We use our center, which is at -1, -2. So you want to come down here. Once you select that tool, find your center. So -1, -2, and you want to click at that so we can set that up. And then for your equations for the asymptotes, let's take a look at that. So since we already selected our asymptote, we already selected our center for the equation of the asymptote, I actually go back to the standard form. And again, this is where, and I know my writing is kind of obscuring some of this, but hopefully you can still see some of this. So you can see this is going to be the standard form for the equation centered at 0, 0 with your hyperbola opening up and down, right? So you can see how the equation for the asymptote in its basic form is given to us as A divided by B over X. And then of course the plus and minus for, the slope of the line being positive or negative. So this is kind of what you want to keep in mind. The A divided by B value is what we're looking for. And in this case, you can see the A is associated as the denominator of the Y value and B is associated as a denominator of the X value. So using that, we want to see what the A and B values will be for this equation over here. So you can see our A square is the denominator of the Y, which is coming out to be 4. So that tells you A is going to be square root of 4, which is going to be 2. For B square, you will see underneath the X value, there is actually no denominator. So that's understood to be 1. And then, of course, square root of 1 is going to be 1. So for the equations for our asymptote, where you have the general form of plus or minus A over BX, you can kind of think of these equations as being plus or minus 2 divided by 1x, right? So once you figured out where the center was going to be for your hyperbola, now use the slope of that line to create our asymptotes. You can see we need to remember slope is rise over 1, so that's going to be going up 2 units and then going right 1 unit. I'm just using the positive direction for this to keep it simple. So starting at the center, I'm going to go up 2 units and I'm going right 1 unit. Okay, just to show you again, back at the center, I am going up from this, just moving my mouse 2 units up and 1 unit to the right, and I click. And you will see that's all you really need, because the center, and then once you come up with those equations for your asymptotes, it actually gives you the graph for your hyperbola. And now I can check to see if we did this correctly. So I'm going to submit. Now I am in teacher mode, guys, so this will look a little bit different, but you can see it's telling me I got a score of 1 out of 1. So that tells you that I did this correctly. So yeah, I mean, being in the teacher mode, it just looks a little bit different, but obviously in student mode, it would have told you the same thing, right? It would have given you the little green check mark and told you you had the right answer. So this was for a hyperbola opening up and down, so you can kind of see what this would look like. Now, you would obviously use the same kind of reasoning if you were looking at a hyperbola opening left and right. And if you guys want to see that example really quickly, I can do another similar question over here. So let's click on that and you can see my equation changed. Let me clear up some of my writing over here so you guys can see this a little bit better. So of course our opening will change, our center will change, and then the equations of our asymptotes will change. So let's take a look at this guy over here. So you can now see we have the x variable showing first in our equation. So this is definitely telling us our equation is going to be opening left and right. Center, you can see in this case, our x value is x minus 2. So that tells you the 2 itself is going to be positive 2. So you will have the x coordinate for the center as positive 2. You can see this guy is y minus 1. So that tells you the y coordinate is positive 1. So you've got 2, 1 as the center for this hyperbola. Now, since this is a hyperbola opening left and right, let's come back over here. So in this case, you will now see the a value is associated with the x variable and the b value is associated with the y variable. And then the equation of the asymptotes will change. It has now become b over a times x, and again, plus and minus for the slope. So you're having to think about, okay, b over a times x, right? And then remember, the a value is for the x coordinate and the b value is for the y coordinate. So let's come back to our equation over here. So you will see x has again a denominator of 1. So that means our a square value is going to be 1. Let me move this up a little bit so you guys can see that better. So of course, square root of 1 is 1. And then y coordinate is, the denominator is 9. So that's your b value. So b squared is 9, which means square root of 9 is going to be 3. So now when you come up with the equation of your asymptotes, that's going to be plus or minus. And remember, this is now b divided by a. So that's going to be 3 divided by 1 x, right? So now we have the equations for our asymptotes. We've got our center. So let's go ahead and graph this. Now remember, this is a hyperbola opening left and right. So we want to select this little tool over here. So this is the tool we went with this time. Starting with the center, which is going to be at +2, +1. So this is where our center is going to be. And then from the center, we're going to use the equation of the asymptote to get our lines. So let's see, this is going to be +3 over 1x. Again, I'm just going with the positive slope. So from the center, we go up 3 units, 1, 2, 3, and we go right. And you can see again, that's all the information you need. We've got our little asymptotes. We've got the branches of our hyperbola opening left and right. So once again, let's go ahead and check our answer. And look at that. Again, we got 1 out of 1. So that tells us we did this graph correctly. So I hope this helps you guys out in coming up with the graphs of these hyperbolas. And again, if you have any questions, let me know. All right. Have a great day, guys. Be careful. Bye-bye.